So just to back up for those who are just attending, step one was to state the null and alternate hypothesis for the practice question. I then calculate the means and standard deviations for the two variables. This is a dependent means. My dependency is household. So each cat and each dog is related or dependent. They're coming from the same home. Calculate the difference scores. Then I calculate the standard error, which is the standard deviation over the square root of n. Calculate my t observed for my paired means t-test. My degrees of freedom, which is 4. Then I'm looking at my t critical. So for my t critical, I go to my weekly learning. Oh, course information. Statistical tables. So I need my t distribution table. And I have, I'm assuming alpha, and I should state alpha. I didn't state alpha. Always assume alpha is equal to 0.05. So step 6, find t critical. If not provided. Okay. So I'm going to look it up in the table. So I have 4 degrees of freedom. I'm looking for alpha 0.05, and there's my t critical from the table. So I'll just grab that. I'm just going to throw that. Where'd it go? Oh, sorry. So just for the solution, I'm going to throw that in there. So t critical is now I have to know because my alternate hypothesis was less than MD. Oh, why me? Make sure I have my symbols correct. Sometimes Excel can be such a pain. Okay. Okay, so it is, since I'm expecting my alternate hypothesis is on the negative side. I'm expecting a mu d less than 0. So my t critical is not positive 2.132, it's negative. So negative 2.132. Since t observed is, if I look at my critical values, I have to flip this thing around. Because my t observed is in my critical area, meaning that it's further in the extreme scores on the negative side of the curve, right? The lower values, it's more extreme than negative 2.13. So my decision, reject HO. Okay, so that's the way to do it in SPSS. Now I'll just run through it in Excel. Now I'm going to replicate my findings. State your conclusion. Okay, so now I'm going to just run through this in SPSS. It's a lot quicker, far less painful. My apologies for the pain and suffering I forced you to endure while I was fiddling with fonts and stuff in Excel. I got so distracted that my poor feeble brain messed up the alternate hypothesis. Okay, so I'm just going to copy and paste my data in. var1 is household. var2 is cats. var3 is dogs. Okay, so I'm just gonna go with those variables. Cancel. Now I'm going to do my analysis. It is a dependent means t-test. Compare means, paired samples, cats, dogs, and then I go okay. Okay, so now hopefully if I haven't messed this up, should replicate our findings. So I'm just gonna, so we can do a parallel view here. My T observed is negative 2.36. Yay. My standard error is 0.68. Yay. And for a one-sided t-test, my p-value is 0.039. I reject the null hypothesis. Yes. My means were 6 and 7.6. So I state my conclusion. And my conclusion is, whoa, what the hell did that come from? Jesus Christ. So if I do this in APA style, but I'll insert a new text box. The cats were younger than the dogs. M equal to 6.00, comma, SD equal to 3.16. And you are younger than the dogs. M equal to 7.6, comma, SD equal to 4.16, comma, T with 4 degrees of freedom equal to negative 2.36, comma, P less than 0.05. There's my conclusion. And I'll make that a lovely 14. Ta-da. I said 14. Anybody have any questions on that? Is it useful to go through that? Okay, so that's question 1 as a walkthrough. Okay. So let's call this Q1. And I'm just going to copy. Okay, so this is Q2. Okay, now attempt Q2. Okay. So I made a mistake. So I made a mistake in my so the null hypothesis, mu pet food equal to 35. Alternate hypothesis, mu pet food not equal to 35. Assume alpha 0.05 not true. Assume alpha equal to 0.05 if it's not provided. Find T critical. Key thing here is this is a two-tailed test. So I'm going to have 2 T criticals. So there's a T critical for mean less than 35. And there's a T critical for the M greater than 35, right? Now the T critical is going to be my alpha is 0.05 if provided. It's a t-test is 2 T criticals for each alpha equals 0.025, right? Because I got to, I have to split the alpha in half because I have a, I have an H1 for mu less than 35, and I have an H1 for mu greater than 35, as we discussed last week. So I actually have two T criticals. So I have a T critical for the sample mean less than 35, which is associated with the null hypothesis mu pet food less than 35. I also have a T critical for a mean greater than 35, which is for the alternate hypothesis mu greater than 35, right? So there's two alternate hypotheses. We have two-tailed. That's why you got to take the overall alpha of 0.05 and divide it by 2. Okay, so now I look up now in my table. I'm looking up not a critical value for 0.05, but for 0.025, because those are my two critical T values, right? So when I go to my, where did it go? Oh, I know where it is. Sorry. So now my T critical is not for 0.05 because I have two alternate hypotheses. I take the 0.05 and divide it by 2. My T critical is now for 5. I have 5 degrees of freedom. Do it 5 degrees of freedom. Oh, shit. 4 degrees of freedom. Oh, good. I did have it right. So my 4 degrees of freedom, I have 4 degrees of freedom. My T critical is 2.776. So I'm just going to capture that and put it into the solutions Excel spreadsheet. So my T critical for 4 degrees of freedom for the and is for the alternate hypothesis mu less than 35 is equal to minus 2.776. And then plus 2.776 for the other alternate hypothesis when because it's two-tailed. Okay, so my T observed is negative 2.35. My T critical is I'm on the negative side because my mean was less than 35. I look at the negative 2.76. And because negative 2.35 is not more extreme than negative 2.776, like negative 3 or negative 4, an even lower value, I failed to reject the null hypothesis. So then the amount spent on pet food with a mean of $31.00 with a standard deviation of 3.81 did not differ from the from the national average of $35. T 4 degrees of freedom equal to negative 3.5 P not significant NS. There. The amount spent on pet food did not differ from the national average of $35. I can put a thing down. Put that. Comma. I don't need the comma, but I'll just. Okay, so does everyone have any questions on that? It's the two-tailed one that I wanted to get at with this one. Now I'm going to do this in, let's do it in SPSS. So I'm going to add my dog's age or the amount spent. I got to not just have it as number. Control copy. I'm going to add that to my SPSS file as another variable. Okay, so And give that one a label. Okay, so now I'm going to run my t-test. Compare means. This is a one sample t-test. The test variable is the amount spent on pet food, and the test value is, which is the null hypothesis, is 35. Then I click OK, and voila. So let's make sure that what we did in Excel matches up. Trying to find a little space there. Okay, so we had a mean of 31, a sample standard deviation of 3.81, my standard error of 1.7 or 1.7, yep, 1.70. My t observed of negative point. Oh, that's sorry, that's gonna push out the decimal place. So my t observed is negative 2.39. Now, when I look at my significance, I have to go to the two-tailed significance. So my two-tailed significance is 0.079. I failed to reject the null hypothesis. Now, what does SPSS do? SPSS figures out the p-value for my given t observed. So for the negative 2.349, the p-value is 0.039. But because it's two-tailed, that's the p-value for a one-sided test, just for that one half. It parallels it and doubles that value. So it's 0.039 times by 2. Right. So if I kind of like if I take this out, sorry. So this is, I'm just going to throw it here. So this is the SPSS one-tailed. I'll just show, control copy. Now, if I take the 0.039 and times it by 2, oh, let's see, 0.61. Mine's not quite as accurate. So there's the p-value. So that's how SPSS deals with that. Okay, so what I can do is I'm going to take the I'm going to take this and put this. Oh, I know what I have to do. Sorry. So I'm just going to copy in the SPSS output in here. So this is for the one sample t-test. And I'll just throw that in there. And then I'll do Q1. I'll put its output in SPSS2. I'll put the SPSS output. I'll just put it as a picture. Does anybody have any questions on that? Now, this isn't going to print very pretty. So I'm going to call this the solution. And I'll post that to Blackboard. And I'll stop my recording. So that recording